This video covers Faraday's law. Faraday's law states that the induction process occurs whenever the number of magnetic field lines cutting through a loop changes. So let's elaborate a little bit on what this means. So here we have a magnetic field pointing upwards. We then place a conducting loop within the magnetic field. If we rotate this conducting loop, we will change the number of magnetic field lines that cut through the loop. So we go from all 3 lines cutting through the magnetic field to just 1, and then back to 3 again. So whenever the number of magnetic field lines cutting through the loop changes, there is an induced current within the loop. This induced current comes from an electric field that is also introduced into the wire, as shown. Ways that we can introduce current into a rotating loop is as shown with this example, and also the rail system that we covered in the previous class. So let's show another way the number of magnetic field lines cutting through a loop can change. So here's a bar magnet with several magnetic field lines coming out of the North Pole, and they will eventually enter the South Pole. We will introduce a conducting loop close to the north end of the magnet. Notice how there are 6 magnetic field lines cutting through it. If we move the loop down, the number of magnetic field lines cutting through the loop will decrease, since the magnetic field strength decreases the further away from the magnet we get. So since the number of magnetic field lines cutting through the loop changes, there is an electric field introduced into the wire and therefore an induced current in the wire. A simplified version of Faraday's law is simply that a changing magnetic field creates an electric field, since the electric fields are what create the current.